Thanks everyone tonight for coming to my presentation. It's titled JavaScript Back to Front, and that's a little wordplay, and it's alluding to the fact that I'm going to be talking about how JavaScript is being used both on the server side, which is the back end, and of course the client side as well, which is the front end. So I'd like to kick things off with a quote from George Bernard Shaw, and he was a playwright from the 1850s, and he said something that, he coined a quote that I think resonates more truly today than even in his own time. And that is, "Some look at things that are and ask why. I dream of things that never were and ask why not." And without engaging in too much hyperbole, I think that by combining server-side JavaScript and client-side JavaScript, we're at a stage now where small teams of developers, so 1, 2, 3-man teams can think of ideas and build them without within 5, 6 man-months of effort. And that's something that even 15 years ago would have been difficult. Like if you wanted to build big networked peer-to-peer applications, it would have been a big engineering effort. So what I want to do tonight is go through a smorgasbord of Node.js applications to show, I guess, some of the things that are possible. When I first spoke to Craig and I asked him about the composition of the audience, he said, you're going to get everyone from total beginners to people who are scary good. So with that in mind, I've tried to put things in where everyone's going to be able to take something away. We've got a lot of demonstrations, high-level talk, and then we'll also get down and dirty and go through some code samples, some technical things for the people who are a bit more advanced. So I guess the first big question is why bother? I'm assuming most people here have experienced JavaScript from the server side, and the first big question is why bother with server-side JavaScript at all? And the simple answer is that Node.js is tailored for building web apps such as Facebook, Twitter, like all the peer-to-peer messaging, all of the real-time updates. Node.js can handle those things really easily, and I'm going to demonstrate some of those in a little bit. And even desktop applications such as Office is, it's facing some vigorous competition from Google Docs. A lot of your traditional database desktop applications are being migrated to the web because it's portable, it runs on multiple devices, and it's cross-platform. And this, I noticed John's presentation was not in PowerPoint. This presentation is not in PowerPoint, it's just running in a browser, and I think that's the way that a lot of applications are heading. So I'm an author through SitePoint, and that's how I met Craig. And just to foreshadow something that I'm going to call on a volunteer a bit later in the presentation, and I brought a copy of my book, and the first person to volunteer will be either rewarded or punished, depending on how you view things, for their bravery with a copy of my book. Now, my initial thought was I was going to spend the whole presentation just talking about one aspect, but I thought that would be a bit too narrowly focused. So instead, what I want to do is just give a brief introduction to the software that we build in the book, because I think that will be different from, I guess, what you traditionally see from a client side. So I want to talk through that, and then move on to another, like a different facet of Node.js. So to start basically to run this application, we need two things. We run a database server, and the database that's commonly used with Node.js is called Mongo. And the interesting thing about Mongo is it's JavaScript based as well. So everything is just JSON and JavaScript related. So I'll quickly tour through the Mongo client, and you'll get a better idea of what I'm talking about. So we're going to use a database called Market. I hope everyone can see that. And when I say show collection, the collection is like a table in Mongo. So what we can do is we can do db.transactions.find, and this will show, this is the actual data that's in the database. And I hope it's obvious there, but that's basically just JSON. So Mongo is a database. It's in fact faster than SQL, but instead of having to learn a query language or a new format. Everything here is just JSON, to the point where if you want to run a query, that runs in JSON as well. So this is just listing all the transactions in the database. So if you want to do something like filter by a particular stock, we can just do stock NOC3, and that will filter just the trades that have come up which have that match that particular query. And if we want to further drill down and look at things where, for example, the price is greater than 40, again, it's just it's the JSON format with which you'd all be familiar. So we can just say price is greater than 40, and that'll filter for all stocks that are called NOC3 that have a price greater than 40. So what I want to do now is jump into the app, and so we'll run it like that. And it's got a lot of the standard features of web apps. So you can sign up as a user. So, and you can log in like this. And so the first little thing I want to show you is, so it's a stock market focused application. So one of the things we do is if you want to search for your stocks, like Google or Apple, it'll add them to a portfolio, store that in a database, and retrieve real-time prices from the web. So this sort of thing is very easy to do in Node.js. And the crux of the application is this next little screen here. And I hope you can see it well enough, but what's happening there is the numbers are flashing around and changing on the screen. So, and what it represents is, on the back end, in JavaScript, we've built a little, a mini ASX, if you will. So it's a little stock exchange running in the background. It's generating random orders. There's an order matching engine, and it's generating all the trades and it's sending it through to the front end. And all these prices are being updated in real time. So just like the ASX, you've got a lot of orders on the buy side and the sell side, and that's showing the transactions as they come through. And the reason I chose to do something like that is it's something that you wouldn't traditionally see in built-in JavaScript. If someone was going to say, build me a stock market engine, most engineers would immediately think C, Java, and I wanted to do this. It's sort of like John was saying, you just have a little thought experiment and you see if you can do it. I thought, this is probably going to work, so I sat down, built it, and it works just as I hoped. So you probably wouldn't use it in an actual trading situation because that among a number of things. But I think you could build a lot of from a simple idea like this. You could build educational things, trading simulators, stock market games. So there's a whole world just from this one simple idea. It opens up a world of possibilities that before server-side JavaScript came around, like it's something that would be a lot more difficult to do just from a client-side perspective. Yes, I just wanted to give a brief overview of that, just to, I guess, perhaps open some minds about things that can be done in JavaScript these days. Now, I'll stay high level for now and answer some questions about why should you learn what might just appear to be another framework. Well, I know we have a Rails developer here. There's Django. There are all sorts of great frameworks out there, and there are a couple of reasons that I'll present. One, Node.js is very fast, so benchmarks are always controversial, but I think it's fairly well accepted that Node.js is faster than its peers, which would be languages like Rails and Python. So if you have a look at benchmarks around, commonly you'll see things, Node.js is about 10 times faster than Ruby 2. And I think that's a pretty incredible bench. Like the two things that are comparable languages, they're weakly typed, they're not compiled. To achieve an order of magnitude in speed up is quite an impressive metric. And that's mainly because Node.js runs on Google's V8 engine. And the guys at Google have optimized that extremely well. Secondly, Node.js is asynchronous. And what that means is if you, again going back to something like Python or Ruby, traditionally how they'll work is if a request comes in, it will use a thread, and if a request comes in to query your database and that request takes a long time, that thread will block and no one else will be able to access that thread while the query is being run. And so what will happen is if you have thousands of concurrent web requests coming in, the architecture is such that thousands of threads will fire up, and there's a lot of overhead just in managing those threads, and it's one could argue that it's not the most efficient architecture if you had the web inline. So JavaScript is just single-threaded, nothing blocks. So if you're doing a long database query, it'll just or a network query, it'll work through callbacks, and the main thread won't block. It can handle hundreds of thousands of requests on a single thread, and it's not going to go through the overhead of managing lots of different thread pools. And the last thing is, real-time is really easy. The prototypical example of Node.js is a chat application, and historically it's been a little bit fiddly to do things like that, but in Node.js, chat applications with the help of a library called socket.io can be built in 10, 20 lines, and I guess that's where some of its strengths shine through. And the other benefit of Node.js is you get to use one language all the way through. JavaScript is everywhere from the client to the server to the database, and it might seem like a trivial thing, but if you're working on web applications across the whole stack from the front end to the back, and you have to port code from the browser side to the server side or vice versa, a lot of friction gets involved in the process. So once you have a single language and a single interface across everything, you'll start to notice a lot of benefits that might not seem obvious. There are some drawbacks to Node.js. I'm not an unashamed fanboy. It's quite a new technology in that it's not even at version 1 yet, which means that things might change between where it is now and once version 1 officially gets released. Best practices are still emerging, so I guess there are little pockets emerging of what people consider the right thing to do, but there's no, de facto right way of doing things. So Python has, our philosophy of there's one way to do things the Pythonic way, and Node.js, it's still a bit rough around the edges in those regards. It's harder to find developers, so I did a look on Seek a few days ago, and there are about 50 Node.js jobs, which is, when I first started there was one, so it's an improvement, and whereas JavaScript there are about 2,500. So if you're looking purely from an employment perspective, it hasn't quite hit the mainstream yet, and it's untested at huge scale. So Facebook, Twitter type companies, to my knowledge, there are no companies at that stage who have used Node.js. And it's not to say that
LinkedIn does.
LinkedIn
for their mobile app.
But that's not the main backend. That was my understanding was it was a small part of their site rather than thing. But I'm not sure.
Yeah, I think they replaced like 300 machines with.
All right, well, I'll stand corrected. on that point. So now I want to move on to something different, and this little graphic here is Candy Crush. I'm not sure if you've played it, but it's a popular game. It's pretty addictive, and I wasn't attracted to it by the gameplay elements, but by this couple of metrics that I'm going to reveal now. So since we're in the Atlassian building, I thought that would be a good reference point. And according to Wikipedia, Atlassian made $102 million in full year 2011. Candy Crush makes $19 million per month. And there's another game out there called Puzzles and Dragons, which I've never been able to play because it's not available to Australians. It's apparently big in Japan. And they apparently made $113 million in April. And so this is the kind of metric that attracted me. And if you do some research on the makers of Candy Crush, the maker behind that game is called King, and their philosophy is to hire small developers in 2 to 3 man teams to build, small groups of developers. You have to call for a water. You're in trouble, Darren. Small teams of developers, so 2 to 3 man teams working for 2 to 3 months. So Candy Crush was produced in, I would estimate, 4 to 6 man months. And that's the kind of thing that excites me, where you can get a small team together, think of a cool idea, build it, and there's a platform now where you can release it to the world, and the rewards are quite substantial. So the crux of the presentation today was, I thought, again, another thought experiment. I thought, well, can we build a game in Node.js? And The genesis of this idea was I did an online course through Coursera called Interactive Programming in Python, and they built a whole bunch of games in Python and munged it around so that it managed to work on the web. And one of the games was Pong, which was, some say, the game that launched the video game industry. And I did the course. It was an interesting thing. I learned a lot, but at the end of it, when I had my Pong game, there were a couple of problems with it. One, Python is not really designed for the web, so we had to run it in their sandbox. And two, it wasn't a multiplayer game in the sense that it was multiplayer in the sense you could play two people at one computer, but not in the sense that you could play it across the internet. So my little thought experiment in that regard was, is there a way to make it run across the internet in real time? So this is the original Python one. I'll just quickly bring it up to show you guys what it looked like. I obviously designed the people with very quick reflexes, but this is the basics of the Pong game that we built. And
everybody wins.
So now, I guess I'll do it now. I'll call for volunteers. So I would like someone to have a game of Pong with me on Craig's laptop, I believe. Any takers for that? Otherwise, Craig has volunteered. Thank you very much. Would you like to come up?
Little bonus to him. He was the Pong champion.
What was your name?
Michael.
Michael. Nice to meet you, Don.
Nice to meet you.
So would you be able to fire up Craig's laptop and...
There's a password.
That's true.
Little developer.
And this is still a proof of concept, so it's not bug-free by any means, but the concept I wanted to show was a game running across the internet in real time with sort of real-time scores and communication. So what I'll do is I'm going to jump on this URL, and if you can connect to the same one.
You know, I don't trust playing the developer of a game.
Against WRC.
Little backdoor. The house always wins.
You said it's the early stages, so it's probably okay.
Okay, so just hit enter when you're ready. And there it is. So if you move the paddle, arrow keys are moving the paddle. There you go. So I'm not, and so that's the other paddle there. And if I move around, and we have a bit of a game. All right, so that's the concept I wanted to show. So I'll break it down now. But thank you very much for volunteering. And your copy of my book is promising. And yeah, I'll let you take a seat.
Oh, he's making a comeback!
So I'll break this down from the client side and the server side. On the client side, there are two main ideas. The first one is how do you draw the thing, and we use the Canvas API, which John touched upon. So it's once you get into it, the things you need to build the game, it's a fairly intuitive API to use. And the other main option was SVG, which we didn't use because Canvas is more JavaScript friendly. SVG is more XML based, but it does have the interesting property that if you want to zoom in or zoom out, you don't lose resolution, as the name scalable vector graphics implies. Whereas with Canvas, because it's bitmap based, if you want to zoom, if you need to zoom into an image, you'll lose that resolution. So I just took some very simple code snippets out, and hopefully you can just think of it as it's almost just like a painting program where what we did with this particular thing was we just moved the cursor to a particular point, drew a line to a particular point, filled it, drew colors, set line thicknesses, that sort of thing. So if you have a fish around the API, to be able to draw sort of a basic table and some circles, that will come out fairly readily. And the other aspect is how, once you've drawn your table, it's how do you animate it. So conceptually, all you're doing with animation is displaying a rapid series of pictures. So movies normally come in at 24 frames a second. A game will run at about 60 frames a second. So the first thing you might think of if you want to refresh a screen at 60 frames a second is you'll use JavaScript's inbuilt set timeout, which it works. It's not, there's nothing horrendous with it, but the problem is on a phone or in a browser there are all these competitors for CPU resources, and set timeout is a bit of a naive implementation in that it doesn't really take any of those factors into account. So you're going to have, depending on what else is happening, you're going to get variable frame rate, it's going to appear jerky. And a better way to do it is to use a function called request and in-frame. And the top of that screen there is just a cross-browser compatibility check. So we're saying if you've got that function, use it. Otherwise, fish around for other vendor-specific implementations. And as a final fail-safe, if you will, we can still have the set timeout implementation in there. And then to use it, it's very simple. You don't have to the code just at the bottom here. You don't have to specify frame rates or anything. You just pull it there with your draw function, and it'll take care of everything for you behind the scenes. Now on the server side, there are three main ideas that I want to communicate. The first and simplest is the concept of a route. So that's if you go to Facebook and you go to /myaccount, the my account portion is the route, and the first thing you need to do is specify a function that will handle what happens when you go to my account. And here I've just left a blank function as a stub. The next portion is the business logic. So after you've gone to my account and you say, here's the function that handles it, generally what you'll do in server-side programming is you'll go to a database, you'll grab a few things, you might go to the web, create some prices. So this is an example from the stock market application where if someone goes to the route /API/trades, we'll have a function here that grabs some transactions from a database, it'll get a trades array, it'll do something like that, grab them into a JavaScript variable, and then it'll push it down to the client, which brings us to the third part, which is views. And generally views can be thought of as HTML with a bit of markup. So here we've got some plain vanilla HTML, and we've got a markup here around email. So what would have happened on the server side is it would have grabbed someone's email from a database, and here it'll display it to the client. And I guess for those of you who don't have a lot of server-side experience, the reason you break it might seem a bit arbitrary, but the reason you break it down these ways, it's a pattern that's proven successful. In the early days, some people were mixing business logic into their views, and they were mixing HTML code into their business logic, and this just led to something that was pretty unmaintainable. And as code bases grew bigger, it led to spaghetti code. So formally, this is known as MVC, a model view controller architecture, and it's generally one that stood the test of time. And I want to quickly mention Socket.io because it's one of the main attractions of Node.js, where it can be thought of as jQuery for sockets. And what I mean by that is, if you're looking to do real-time things on the web, you've got a whole bunch of technologies around. You've got long polling, Comet, WebSockets, and they are from different browsers, support them to varying degrees. So if you wanted to do all this by hand, you'd have to do a lot of checks. You don't do a real-time app, you'd have to check for each of these things. Does this browser support Comet? If not, fall back to long polling, and so on. And Socket is just a really nice, it's just a really nice wrapper where it presents a simple API. You can do a lot of real-time things in very few lines of code. So I just want to give my final demo, which was an app that I did a while ago. It was when I was working for a startup in Philadelphia, and we presented this app as a little programming problem, if you will, just while people were on their trial period. And it's a blog application, and if you're looking to test your programming chops in terms of server-side programming, once you get this done, it's a pretty, it's a good milestone to reach. So what I want to do is, that's your typical blog engine. I might, Craig, if I could just borrow your,
Asterisk. Never gets old, that one.
And so what I'll do now is I'm just going to log onto the blog from here, and I will I'm going to post a comment, and the idea is that it's going to be updated. It's going to be updated in real time after I post the comment. And yet, traditionally, you'd have to muck around with quite a bit to get something like this going. But in using Socket.io and Node.js, it's literally 3 or 4 lines of code, and you just get everything everything working out of the box. So just clicking on the post. Yeah. So I'm just going to type a comment. Yeah. And I'm just about to hit submit. Hopefully, it appears in real time. So I guess that's a brief overview of 3 kind of different applications that you can do in Node.js. You've got a you've got a stock market application. You've got a real-time game. You've got a blog, and all of these things are very quick to do. And I guess as I mentioned at the beginning, as recently as 5-10 years ago, doing those 3 things would have been quite a big engineering task. You probably would have needed a fairly big team. So I hope that it's given you some ideas, or I guess of what you can do. And if you guys have your own ideas, you can, I guess, start having a play with Node.js and client side, and seeing if you can, become the next Candy Crush or Puzzles and Dragons. So that concludes my presentation. Do we have time for questions?
We sure do. Do you have any questions on the floor? We do.
How do you debug on the server side?
There's a client-side debugging tool, but basically, if you're familiar with, I guess, Eclipse, so it works similar to that. So it's sort of like an IDE in the browser. You set your breakpoints, and you run it through. You can step through. So it's essentially the same as what you get with Eclipse or Visual Studio or anything like that. So in that regard, tooling is up to par.
Studio is like IDE, like Web Storm or PHP Storm, is integrated into IDE, so you will actually have proper debugging there as you get used to. So just connect it to your server, it will handle it.
Right.
Or you debug it with your Chrome browser.
Yeah, so I was talking about the Chrome solution, but yeah, there might be things you can just go straight from the IDE as well.
One more question. Down the back.
You mentioned that an advantage of using Node is that you can share skill sets between the server and the client. How viable do you see that being, though?
Yeah, not necessarily skill sets, because I understand that client-side engineer is going to have a very different skill set from a server-side engineer. And so I guess to give a specific example of what I was talking about, if you're building an application, you might have, say, PHP, JavaScript, and SQL. So you might have 3 languages there which are largely not interoperable. Whereas with Node.js, you might have a function that does some sort of calculation on the client side, and if for whatever reason you decide to shift it into the server, you can just move it across fairly seamlessly. And similarly, in the database language is just JSON. So if you're doing a database query, you don't have to worry about, do I have to store SQL, do I have to serialize objects? All those kind of interoperability issues, they're largely gone. So because the database just talks in JSON, you can move JSON from the database to the client to the server, and I've found that it just reduces friction. So it's not so much about sharing skill sets, but it's about reducing friction when you need to move between them. Yes.
On that, how
Sorry, what was that?
how common do you find that happening?
I can give you an actual use case. So as an example, one thing we were doing, looking at building, was in a stock market application, if you wanted to create, if you want your users to be able to create trading systems, and they want to do things like, well, give me all stocks that have a dividend greater than 5% and a return on equity less than 10%. If you wanted to do that sort of a query, traditionally you'd have to write it in SQL, figure out some way to store SQL in the database and transform it back and forth. Whereas with Node.js, all we had to do was we wrote the query in JSON, we stored it in JSON, we retrieved it in JSON, and then when it came time to display in the browser, we didn't have to make many changes at all. So it's in terms of sharing skill sets, it's I haven't seen that much, but in terms of transferring code between different portions of the application, it is quite handy. And once you do it, you'll just see things where previously you might have avoided things because they were too difficult, or you might not even thought of doing them in a particular manner. Just new solutions and new paradigms open up, if you will.
Can we all thank Don for his time, please?